If you find that this explanation is a bit difficult to understand, there's actually another way. If you have the time, you can actually put in values to test for yourself. Okay, let's try this. Let's give some values to it. Let's assuming the voltage here is 240 power supply, and let's make an easy assumption. All the long transmission cable each will be 10 ohms, and the bulbs will be 10 ohms, 10 ohms. And if you know both are 10 ohms, you find the total effective resistance in parallel, 1 over 10 plus 1 over 10 in the back. The total resistance across the bulb would just be 5, half of it. So the first thing you need to do is to find the total effective resistance, which is 25 ohms. So I want to find the main current flowing through the circuit, okay, which is here. So it will be V over R. I use the EMF, and the total resistance is 25, and the main current will be 9.6 ampere. So because the two bulbs are identical, basically they'll split 4.8 ampere here and 4.8 ampere here. So now if I need to find the potential difference across Y, it will be V equals to IR, and the current flowing through Y will be 4.8 times the resistance, which is 10 ohms. I will get 48 volt for this scenario before lamp X is being switched off. So what if now I switch off lamp X and I left with Y? So this will be 10 ohms, 10 ohms, 10 ohms. The total effective resistance will now be 30 ohms. So let's look for the main current again, V over R, and it's the same voltage, EMF 240 divided by 30, and now the main current will be 8.0 ampere. So it's a constant 8.0 ampere throughout the three components here. So if I need to find the voltage across Y, V equals to IR, the current is 8.0 times the resistance 10, therefore I'll have 80 volt. So can you see the voltage across the Y before X is closed is before X is switched off is 48. Now it has increased to 80 volt. So we have settled the part for voltage. Then how about power? And if you know, power equals to IV. So the current flowing through the bulb Y will be 4.8 times the voltage across it, okay, which is 48, and that's where you have the power across the bulb Y will be 230.4 watts. So how about when lamp X is switched off? So the power for Y will be IV, and the current flowing through is a constant 8.0 times the voltage across here, Y will be 80. So you have your power is 640 watts. So once again, from previously 230.4 watts, now it has increased to 640 watts. So that's one way you can do. Of course, this will be a more tedious and longer way to do it, but it can convince yourself. So that's how you solve this question.